Hello everyone, my name is Hassan Suleiman. I'm from Electrical Power Department, and today I will talk about the unit decibel, or dB in short. Decibel is a unit made of two parts, the first part being deci and the second part being bel. Deci is 1/10 or 10 to the minus 1. For example, if you have a pie chart that's made of 10 bars, the part in red is 1 deci of the whole chart. And just like 1 millimeter is equal 0.001 meter, 1 decimeter is equal to 0.1 meter. So in our case, 1/10 of a bel. So what is bel? Before I start with bel, I have to talk about logarithm. Linear scale is the one that we all familiar with, where each step is the one added to the last. But there is another scale. Instead of adding, we multiply by a number, which in our case is 3. And that's called a logarithmic scale. An example for a linear scale is this elephant right here. If you have an elephant that's half the size, you can say that the big one is twice as big. If you have an elephant that's half the size again, we can say that the big one is triple the size of the smaller one. In our case, the 2 and the 3 are the ratios, and the big one is a reference because you can't have a ratio without a reference. An example for a logarithmic ratio is our census. It's believed that most of our census are logarithmic, not linear. An example for that is how loud we perceive sound to be. If you have a boombox that's playing at full sound and you put another boombox that's playing at full sound next to it, you will not perceive the sound to be as twice as loud as just one playing at full sound. And if you want to double the loudness, you actually have to have 10 boombox playing at the same time. And to triple the loudness, you actually have to have 100 boombox playing at the same time. You see how the scale multiplies by 10 each time. It's going in a logarithmic fashion, not a linear fashion. So let's go back to bel. What is bel? Well, bel is a logarithmic ratio between two powers, and the equation for that is b equal log power 1 over power 2. And since it is a decibel, we multiply the whole equation by 10. And just like when the big elephant was our reference, our B2 here is our reference. If you want to relate the equation to voltage, you just have to plug in the power equation V square over R in the equation, and you will end up with dB equal 20 log voltage 1 over voltage 2. An example where dB become useful is this simple circuit right here. When there is one voltage in, if you have a negative feedback that made the first amplifier to have a gain of 2 and the second amplifier to have a gain of 10 and the third amplifier to have a gain of 31.6. And to find the total gain of the circuit, you have to multiply all the gains together and you get 632. And to change that ratio to a logarithmic ratio, we have to use the equation above. And we take one voltage in as a reference. You will end up with the first one being 6 dB and the second one being 20 dB and the third one being 30 dB. And to find the total gain in dB, you have to add them instead of multiplying them because they are logarithmic. You will end up with much smaller number, which is 56 dB. But why dB is important and why we use it? We use it because it gives us a way to express large numbers in much smaller scale. dB is commonly used when you're dealing with sound because sound is really interesting. The faintest intensity of sound we can hear is 1 multiplied by 10 minus 12. And the loudest we can hear before we experience pain is 1 multiplied by 10 to the power 1. And that's a really huge range. The largest range in our senses, and it goes from 1 to 10 trillion. If you're going to buy a headset, it's much harder to use normal ratio if you're going to express the capacity of the sound of that headset. As you can see, saying it's rated at 95 dB is much easier and smaller than saying it's rated at 3.126 billion. And dB got adapted to many other units that has a really huge range. You just have to change the reference and you will get much smaller number, a number that will be easier to work with and do calculation with. That's it for the video. Thank you guys for watching.